Principles of pulse echo imaging. There are three different scanning modes, the most important. M mode is the first one, B mode, and the other is the A mode. B mode is the mode that we currently use. This is the mode for pictures of the fetus, the liver. B mode, that means bright mode, brightness mode. The machine put white when the structure that produces the echo is echogenic, gray when the echogenicity is less, and black when the structure is anechoic. Depending on the amplitude of the echo returning, the machine assigns different brights. It's a bidimensional mode, deep and wide, or is the same, axial resolution and lateral resolution. Deep and wide, axial, lateral. M mode. M mode is the mode that we use in ultrasound, in general ultrasound, to measure heart beating. In echocardiography have some use, but in general sonography we use M mode only to measure the heart beating of the fetus or embryo. It's the repetition of only one line. M mode produces these pictures that looking like mountains and valleys we use for measure the heart beating of the fetus. It's the repetition of only one line, only deep. M for motion mode. When we're working with M mode, the machine display a little B mode with a cursor. We use this cursor to put over the heart, and they produce the M mode, the picture that is the repetition of only one line in the time. A mode. A mode is the most crude, the most no computerized form of ultrasound. In A mode, the machine display the amplitude of the echo directly. The use is only in ophthalmology, ultrasound ophthalmologic. This is a very limited use, is not in general sonography. A mode are the echoes, the amplitudes of the echoes directly registered in one line. A mode is called amplitude mode. When an echo returns an upward deflection proportional to the amplitude of the returning echo. That is all. It's very simple. It's only one line with the echoes that return. Frame rate. Frame rate is the number of pictures that the display is in 1 second. Look in the example. One line, two, and when the machine covers all the screen, it's called one frame. Each line is one pulse. Two frames. Each line is 1 pulse. Three frames. The frame rate is in hertz, but not megahertz, not kilohertz, only hertz. To have a good time resolution, you must working at 15 frames per second, but working at less make good picture. Only when you are work at 4 or 3 frames per second, you can see that the display is not good. This is a ultrasound pulse, as you remember. This is the pulse ultrasound wave, time on, time off. You know that this pulse repetition frequency is the number of pulses that the machine produces in 1 second. In general are kilohertz, thousands of pulses in 1 second. Pulse repetition frequency also is in hertz. In general is kilohertz. Higher is the pulse repetition frequency, higher is the frame rate. It's directly proportional. Lower is the pulse repetition frequency, lower is the frame rate. What pulse repetition frequency depends on? Pulse repetition frequency depends on how deep you are working. Pulse repetition frequency is operator adjustable by the deep button. If you are working deeper, you have low pulse repetition frequency because you must wait for echoes that use more time. You change the time of reception when you change the deep. More time waiting for echoes. That means that you are working deeper. Deeper you work, lesser is the pulse repetition frequency because you must wait more time for echoes. Frame rate, of course, is operator adjustable. Why? Because pulse repetition frequency is operator adjustable. And pulse repetition period is also operator adjustable because it is the same as pulse repetition frequency. Adjustable by deep button. Deep is operator adjustable and change pulse repetition frequency and pulse repetition period. Other thing that change the frame rate is the number of focal areas you are working. Phase transducer focus through delay the electric pulse in the beamformer. That is the mechanism that the transducer uses to change focal areas. When you are working with only one focal area, each pulse is one line. But when you are working with more than focal areas,